So welcome today. This is our 7th seminar of Geographic Information System. Currently, I am trying to upload really big files to our Seminar 7 folder. I hope it will be soon there. And we will be able to work with these files. What is content today? What is our topic? So our topic today, I will share on my screen in a text file, because it is probably the only way how to do this. So our topic today is multi-criterial analysis, or you can find it as MCA, or with other words, multi-criterial evaluation, MCE. And this will be topic for the second test. As you can see from the title, we will use a few criteria to evaluate something. In our case, it will be this task: find the best location for a new what is in English? For the best cottage or some house in mountains where tourists they can sleep in an I have it in another computer. So it is some cottage or Alpine hut. I'm sorry. So new Alpine hut in surrounding of Žilina town. Okay, so this is our task. And for this task, we will have criteria that we will evaluate. And for example, one very important condition is altitude. I would like to have this Alpine hut in elevation at least of 1,000 meters above sea level. I hope you understand this word, Alpine hut. Yeah. Then another condition, it is related to protected areas. So near Žilina, we have National Park, Malafatra Mountains. Then we have protected area, Sulawské vrchy. So this new location shall be outside of protected areas. And then the condition will be, it will be the largest possible area. And so these are conditions where we can decide only by two options. true or false. They are like constraints. And additionally, we have some factors, and these factors are the following. So distance from existing alpine huts as far as possible. Then distance from water source as near as possible. And we will have a factor like distance from hiking trails as near as possible. And additionally, it will be important the slope. So as small as possible. So this is our task, and we will solve it using Geographic Information System and now QGIS. So when you compare with our tasks we solved in previous seminars, this is really complex. And we will see if we will be able to solve it today or we will need one additional week. So when solving this task, we need to define what are our map layer. We need some map layers. And a week ago, we started with raster layers. And today, we will mostly have raster layer evaluation. We will use as a main tool will be raster calculator. So all these informations we have like altitude, protected areas, distances. We need raster layers to be able to use then raster calculator. But not all of these input informations are available in rasters. So we will start with vector layers and we will convert from vector to raster. So what you learn today is, for example, conversion from vector to raster. This is one topic you learn today. Another what topic you learn today is calculation of distance in raster layers. So this is something new again. And because we have 4 main factors and they are different. This is distance from existing alpine hut or from water source or from hiking trail or this slope. We will normalize. We need to normalize these layers to be able to combine them. And normalization, it means we will not use units like meter for distance, but we will create something like feasibility using reclassification. So distance from existing alpine Alpine hut will be evaluated from 1 to 10. And for example, 10, it means it is very far from existing. And for example, number 1, it means it is very near. So we will create layers with this information evaluated from 1 to 10. So it is better to see how it looks and then you understand what we will do. We need to specify what inputs we need. So because you see the first task is first condition is altitude, we will need some layer with digital elevation model. And this is a raster layer. And I am currently uploading these layers so I can check how it works. So you can find these layers in Seminar 7. So please start downloading them because again, downloading to your computers, it can take a time. So download these files, maybe individually, it is the better option. And when I will speak during this, it will be downloaded and then we can use it in QGIS. So we will need some digital elevation model. Then we will need information about protected areas. But it is not possible to have some raster layer for this. So we will go to OpenStreetMap and it will be vector layer. Then we will need location of existing alpine huts. And again, we will download from OpenStreetMap as a vector layer. And maybe it is good to additionally to write that protected areas, we will have polygons. For alpine huts, what do you mean? Point, line, or polygon? Point. Point, yes, because this is place where it is located. Then we will need a water source. Okay, again, we will download it from OpenStreetMap and it will be vector layer and point, line, or polygon. By water source, I mean a place you can take water. So we are not drinking water from a stream or from river. We will not take from this, but it's like Q, prameň in Slovak. So it is point where we can take water, okay? So it will be point. And additionally, we need the slope, but slope will be calculated from DEM. And again, it will be raster. And yes, we need these hiking trails. It will be again from OpenStreetMap, vector, and line. Yeah. So we will run today different things. And additionally, what we will need some weight of these factors. So what is more important when we are deciding about this? So I can define now that the distance from existing alpine hut, it is 40% weight. So this will be the most important for us to be as far as possible from existing alpine hut. Then drink water. So water source is the second most important criterion factor with 30%. Distance from hiking trails, it will be the least important because we are able to ask some community to create new hiking trail, and it is cheap. And the slope, yes, it is important, but it will be the third in the rank. You can see that these weights in sum, it is 100%. So we will have a separate lecture for this, and you will see that sum of the weights is 100%. Okay, let us check if we downloaded our files. Yes, it is here. This is very small. Can you compare with your computers?
I'm still downloading, guys.
You are still downloading. Okay, so I will open the first one. And now it looks better, but still it is very small. So probably the first one is already finished. I will move.
5 gigabytes?
Yes, yes. Yes, so I will create a new. Yeah, maybe it was not very good idea to share with you. But so I will create a new seminar folder, and you see what it is. Yeah. So when I go to my files and I put it to the project, it is that digital elevation model, and it takes a time when uploading. So what is very important for now, it is our coordinate system. It is important to check. So you see, this is a really big portion of Europe. Yeah. And Žilina is somewhere here. Yes, here is Žilina. So maybe you know the Váh River is coming here. Here is Malá Fatra on the left and the right. And then the river Váh continues down to direction to south. So, of course, we will not need all the data, but maybe this file, it can be helpful, at least for students from Croatia for semester project. We will check if Croatia is there included. In case you will be not able to download another digital elevation model from some Croatian source, this is alternative. So I think Croatia could be somewhere here. Yeah, this is, we have islands. So probably Varaždin and surrounding is here. And I will check the second file. It is growing. So, but we don't need to wait for this file because I would like to evaluate only part of this file. Yeah? So maybe the second file, we have some online students from Serbia. They can use this digital elevation model for Serbia, and we will see students from France and Portugal and Kazakhstan. You can ask me to help you in case you are not able to download directly from official source from your country. We can try download similar raster. So just to check what are some basic properties. So properties of this digital elevation model of this raster. You can see that extent, it is defined in ETRS 89 coordinate system in meters. And you can see it is 40,000 times 40,000 cells. Data type is float32 to be able to show numbers. You see the minimum is -5, so below the sea level, and the highest is somewhere in Alps. So to be able to use different values, a lot of values, this float32, and this is GeoTIFF file. And what is important? Important is our resolution. So pixel size is 25 times 25. So 1 pixel is like 25 meter in reality. So it is enough for us. But we will not work with the whole file because we are looking only Alpine huts in surrounding of Žilina. So we will make the first operation and we will make the clip. So the second file is there. Maybe just to show the extent of this second file. For example, for Slovakia, we need both files because west of Slovakia is in the first one and east of Slovakia is in the second one. But for Slovak students, it is very easy to download other data. Okay, so we will continue with this and we will make a clip. I hope you remember we used the clip in vector files in geoprocessing tools. But this is a raster. And for raster, we have another menu and there is extraction. So please go to extraction and we will clip raster by extent. So do you have this file already in your computers? This one? Yeah? Is it out? In case it is downloaded, please open it in your QGIS, or you can wait for me and I can clip and upload the smaller file for you. Yeah. So we will define clipping extent. And you can see we have different possibilities. Currently, I don't remember what is the format, how to write it there, but I can help myself because when I use the fourth option, use current map canvas extent. So you see the format and I will just rewrite this. So we need extent like I can continue here to share, to show you. We need this extent 490000. Then we need 2900000 and 50 and 7 zeros. Only 6 together. 1, 2, 3, 4, 5, 6. Yes, and additionally 30 and 5 zeros. So this will be our extent. We need to check how it is organized here. So this is 35. Okay, let's check. I hope it is in correct sequence. We need to have it in correct sequence. So just, I hope it works to copy and, it is not possible. So I can drop like this, but I need to rewrite. And we can see the first number And second number, it is related. Okay, so this will be for us this 490000, and the second number, it will be 50, and like this. The third one, it will be this 29 and this. And the last one is 30, like this. So it is important to have a correct number of zeros. It will be like 5. The main number is 50, and then 1, 2, 3, 4, 5, and 29. 1, 2, 3, 4, 5, and 31, 2, 3, 4, 5. So this is our extent. And yes, we can save for first step only to the temporary file. So save to temporary file. So we can try to run. And again, some important remark is you can see we have something like GDAL console. GDAL, this is a library for geographic analysis. And this geographic analysis library is free, is open, and it is implemented, for example, here in QGIS. So you are able to go to GitHub or something like this to download it and use it in your own tools. So run. Yes. And we can see we have the smaller, much smaller area, and we will use this for our analysis. So we can remove it, the bigger one, from our project today, and we will continue only with this area.
Step really short of it, I mean, see all steps once it's so good.
Yes, so raster, extraction.
Can we do this the first one or the second one? Because there are two things down. 40 or the E40 or E50?
For this, with name where is 40.
Raster, and then extraction.
I did it for this file. E40 and 20. It means easterning 40, northening 20.
Yeah.
So I did it for this. And then I used raster, extraction, clip raster by extent, and then you need right there the parameters. And I will upload it for you. Okay. Yeah. I will upload this for you.
Yeah.
So I need to export, save as. So I will save it as geotiff. And I will put it to my current seminar folder. So the name, it could be like Seminar 7 geotiff. And it is important to select our coordinate reference system. We have some ETRS 89 here, but I will save it as EPSG 3035. Yeah, so I will save it like this. You see, we will keep layer resolution 25 times 25. And now I export it to new file. I can remove this one, and I will remove again this one to be able to share with you. So when I go to my files, it is this one. It is uploaded there. So when we compare the size, really this is smaller than the first one. Yeah, what is interesting, I put it again here. So I can measure or I can calculate what is extent of it. When I go to properties, you see the extent is 4,000 times 4,000. So not 40,000 times 40,000 as earlier, but now it's 4,000 times 4,000. In case one cell is 25 meter, we have like, I think, 100 times 100 kilometers. I can check. I have this tool, measure line, so I can go from one corner to another corner, and it is really in meters. So when I switch to kilometers, yes, it is 100 kilometer. So this is our first input, and based on this, we will download all other layers we need. So for example, let us start with something what is easy. So Alpine hat. First, to be sure we understand what does it mean. So when we go to wiki of OpenStreetMap, Wikipedia for OpenStreetMap, and we write there Alpine hat, you can see what I mean. Yeah, it is place where tourists they can have a accommodation for one or more nights and some basic refreshment. So we will look for this in our OpenStreetMap data for this region. So this is region we will use. So please check if you have already Quick OSM plugin in your QGIS. This is important. So we can go to plugins, manage and install plugin. And you can see when you go to left to install, you can see list of installed plugins. So for example, I have Quick OSM here, and I hope this is the latest version. It is from August 10th this year. So probably it is the latest version. Do you have this?
No.
In case you don't have it, please write, go to the all on the left and write Quick OSM and then install. So after you installed, you will see probably some button to start it. So please use this button, Quick OSM, and you will see this dialog. And we will stay in this offer. On the left, you can select different offers. So this quick query. And I already started this OpenStreetMap Wikipedia. So we know that we are looking for all objects in OpenStreetMap with key tourism and value Alpine hat. So we can write it here. Tourism and Alpine hat. So we are looking for these objects and we will define where. So we have already one layer there. So we will define by layer extent Seminar 7 and we can run the query. So in my computer, I can see successful query, 2 layers downloaded. So when I go back you can see I have something like this, new points, and what is interesting, some new polygons. But I can explain why we have some polygons, because sometimes the mappers, they are creating location of hut, Alpine hut, not only by point, but sometimes by buildings. Yeah. So again, we have to be careful when using data from OpenStreetMap, because maybe you expect, so Alpine hut, this is only a point. I'm looking for points. No. The best option is look for all points, lines, and polygons that are Alpine hut. Yes, what to do now? You see on the left, we have two temporary files. And first, we need to think in which way we can simplify and we can accept some simplification. So this is only in some meters. So in our case, 1 meter, we have 100 kilometers area. So some meters, it is not so bad. First, we create centroids for each building. So we will keep the points, but to be sure we have all Alpine huts in our study, we will create something what is called centroid. So like for this, now we need to start a toolbox. So on the top, I think probably you have this button for toolbox, and simply we will search and write centroid, and then we can find there is a tool called centroids. I hope you found it. So we can start this tool, centroids, and input layer. You see, we have input layer, but this is a point layer. And we have options to select point layer or polygon. So of course, we are selecting the polygon layer. And this is all what we need. Simply we create new temporary layer so we can run. And on the end, you see on the left in the layer panel, we have new centroids, new layer with centroids. So when I move my layer polygons below, you see this building has now own centroid. So I created new points. And I will continue only using points in my analysis. So now I remove polygons, buildings, and I will start now 2-point layers, and I will zoom. So sometimes you see it overlaps. We have several points here, but again, the distance between these is maybe in lower than meter. So it is acceptable for us because we will calculate a distance from this. So we can keep all. We don't need a filter and keep only one for this location. We will check. Yes, so you can see some points, they are outside of our area. Maybe we can think about to clip only area that is below this digital elevation model. So to be able to clip vector points, we need a vector file. So we need some very big polygon, only one polygon. with borders of this digital elevation model. So there are a few ways how to do this, and I will do it this way. I will create from this digital elevation model with a lot of values. I will create a new one, and there will be only value 0. So it will be some how to say, not repeating. I will show again how to use raster calculator. Yeah. So to produce from this Seminar 7 layer, a new one where I have only 0, I simply multiply by 0. So I will receive a result of this to the output. So input is Seminar 7 raster, and new output, I will save it to Seminar 7. So output is like 0 raster dot diff. I will check my output coordinate reference system is 3035, correct. Columns and extent is okay, so I can run. And now you see I have new raster and there are only 0 values. This is first step. And the second step, to have a vector layer with same extent, it will be conversion. So when I go to raster, I can convert this. So I can use this polygonize raster to vector. So input it is 0 raster. And when I am creating a new polygon vector, it will create some column with values and all will be only 0. So for start, this new vector, it could be a temporary file. So I keep these settings and I simply run. Again, you can see GDAL library is used here. Run. And I received a new layer. This is a new polygon. When I go to the attribute table, there is only one object, one feature. Feature ID is 1 and value is 0. So based on this polygon, I will be able to clip only alpine huts that are inside of my area. Before clipping, I need to create one layer from 2 layers. So I go to vector, geoprocessing tool, and I can use union. It means I will create from this algorithm checks overlaps between features. Okay, so maybe not union. Data management. So it is better to use this one. Data management tool and merge vector layers. So please open this merge vector layer. And I will define my input layers here. So it is centroids and tourist alpine hut, not the vectorized, because the vectorized, this is only polygon. So I selected these 2 layers to merge. And I need to think about coordinate reference system. Until now, the both files, they have coordinate reference system with EPSG 4326. It means this is WGS. Yeah, so This one, this extent is in EPSG 3035. So this is ETRS 89 layer. And data from OpenStreetMap, they have EPSG 4326. So it is WGS 84. So we need to create a file with the same coordinate system. So for our study, we will use only this European system. Only this. So we need to convert OpenStreetMap data to the new. So when I am back here, destination, coordinate reference system, it is this one. Again, I create only temporary layer. Run. So now I have, this is layer, these points are locations of Alpine huts. Earlier in OpenStreetMap it was point or building, but now I have all in points. And now I need to select from this. So for vectorized, I will change a little bit symbology. It will be only this red line. So what is inside of red line? Yeah. And we will use the clip. After I will have all layers I need for my analysis, I will share with you all these files. Okay. You remember we already used the clip and you will need the clip for your semester project. So I will clip the data and overlay, it is correct, this is vectorized, and input, it is called the merged. And you see currently I have both vector layers with the same coordinate reference system. Again, I will create only the temporary layer. I can run. And this is finished. So now you see all points, all Alpine huts, they are inside. So now maybe first time I can save it really to my hard disk. So this clipped file, I will export to save it in a geo package. It will be in my Seminar 7 folder. The file name could be Seminar 7 geo package. And the name will be Alpine huts. So now I have some layer that is really saved to my hard disk, and I can delete these temporary files, not delete, it is better to say remove. I can remove these temporary files, and I have this vectorized, so I will save it, I will export it to the geo package as well. So to have this border. So export, save feature as, I will put it to Seminar 7 geo package, and the name would be like study area. So I will remove this. I can remove tourist Alpine huts from this OpenStreetMap plugin. Okay. And I can change the properties, okay, again, to have only these lines. So now I have Alpine huts as a vector. Later, I will need to convert to raster, but for now, I would like to continue with hiking trails, because I need hiking trails. This is one criterium, as near as possible, you see, hiking trails, as near as possible. So I need to download hiking trails. I can go again to Wikipedia. I can look for hiking trails. And it is like hiking path. Okay, we can try hiking path. What is it? Hiking path, but I need something that what is really with some marking. I don't need all. I need really what is hiking.
Can you search out equals hiking? Maybe is that it?
Yes, maybe it is better to go to hiking. Yes, hiking, and we have path, footway or track, surface, and tourism information. So these are the places, guide points, and route. Yeah, this is what we need. Route, hiking. So route, maybe not only the route hiking, and you see this is some relation. So the relation consists of small parts. So yeah, we will look for route hiking. You can see that these hiking routes we have mostly in Europe, and some of them are in East Coast or West Coast of USA. But other countries, there are only really very few route hiking, and we can say that Slovakia and Czech Republic, they are leaders with this key and value. So we go back to this quick OSM plugin. So please now change the key. It will be route, and value is hiking. And now we have seminar as an extent or study area. Now we have more options. We can try look for routes for hiking in seminar 7 study area, and we can run this. So you see this study, it has a lot of steps. On the end, I will mention it is possible to create in Python some model. So we can use some modeler. And in case we create one model, how to look for Alpine huts in area. When we create it once, it could be used for any other locations and areas and regions in the world, in case you will have data. Okay, so it takes some time to prepare this layer. I hope it will be successful. We will have lines, and probably what will be problem, that, yes, we have our area, but it will take not only line inside the area, but in case we have some very long trail from East Slovakia to West Slovakia, it will give us all the line. Yeah. So then again, we will need to clip. Okay, so you see what is the result. And again, surprise, we have not only lines, but you see, we would like to have some route, but it downloaded some polygons. Yes, so somebody created two. So this is some koliba. It means it is some building somewhere in Slovakia. Restaurant, Ulianka, this is near Banská Bystrica. So we don't need this. We will remove from our study these polygons. What we have additionally, we have route hiking like this, one table, lines, and then we have table like this. Yes, maybe you are curious why we have points for this. But points, these are places where you can read what is direction and what is time to come somewhere. I'm not sure, but probably you already were in Dieri, in Malafatra with our Slovak students. And then there were the shields. You can read how far is it somewhere to some destination. But we don't need these points. I remove it from my project. Yes, project. I said project. We need to save the project. So project, save as, and seminar 7. Now I have two files, you see, with lines, so we can compare. We can open attribute table of the first one, and you see in the first one there are 1152 lines, and I expect in the second one there will be more lines. Yeah, 31, 396. So both files, both layers, they contain same information, but the bigger one, it is with small segments. Each segment is separately in the table. And the second file with a smaller number of features, we have there trails that consist of these small segments. So we will remove file with lines with each segment, with these 30,000 segments. So we remove it from our project and we keep only this route hiking where we have 1152 different trails. Again, when I zoom to layer, you see, as I said, this is something from East Slovakia, this is some trail from Poland, international trail to Austria, but we need only hiking trails for our area. But you know, it is easy. We are able to use clip. So vector geoprocessing tools, clip, and from route hiking, based on steady area polygon, we clip this. Yes, we have different EPSG. One is for route hiking. This is coordinate system WGS 84. The second one is for study area. It is coordinate reference system ETRS 89, but it will work. Don't worry, it will work. So we can run. And it is on 0. Oh, yeah, it finished. Clip finished. So you can read algorithm click finished. So now I have only this. So trail only that are in this area. Some are a little bit isolated, but we will not check what is it. We will take all data. We have some international trails there, national trails, regional trails. So we will not explore, investigate the data. Simply we have these lines, and this I will export to my geo package. So export geo package Seminar 7. The name, it will be like hiking trails. And don't forget coordinate reference system. I need to change to the project. Coordinate reference system. This one. This some warning. What is it? Yes, maybe it will be some limited accuracy, but 100 centimeter is okay for us. So this is currently all we need. Okay. And when we speak about this, this is for Europe accuracy 1 liter. I will keep this conversion. I keep this conversion. Okay. So now I have the second input for my study. I have location of existing Alpine huts, and I have locations of existing hiking trails. So when I go back to our file, what we need a water. Again, we will look for it in OpenStreetMap. So let us go. Water source, maybe. Drinking water. Probably. Yeah, we can go to drinking water. Drinking water. This is maybe only tag. So maybe it is better this one, natural spring. Natural, and we have a lot of possibilities. Spring, natural spring. Okay, okay, here. Hot spring, not hot spring, maybe for relax, but this one, yeah. So we will look for all objects. Yes, we need water like this, yeah. So we will look for all objects with key natural and value spring. So we are going to View GIS and we run plugin again. So natural spring in layer extend Seminar 7 study area, and please run it. So what we received? We received some points and we received some polygons. I am not interested in polygons. I will just check. Some 11 objects are like polygons. Maybe this is some shelter or some small wooden building. So I remove this natural spring out, and I will keep only natural spring as a result. Again, some remarks. You can see that probably in this area, in this corner on the right and bottom corner, there are very active mappers. because there are a lot of springs. But we will keep this as we have. In future, if you will have similar study, you can ask for official data from some environmental agency, state agency, but this is just example. So we will continue with this. And again, we need to make a clip. So vector, clip, natural springs based on study area, run is finished. So I can remove. I have only springs inside. So these points. And now I can export this temporary vector file to my geo package. And the name, it will be this is natural spring. And don't forget again, coordinate reference system. And that's all. So now I will share this geo package with you. So I will upload it to our Microsoft Teams because I understand we have a lot of steps and it is really difficult to follow it and do it in your computer. So in case you are lost, don't worry, you can continue using geo package. So I will remove this geo package from my computer for a while. So the geo package, it is here, this one. And this is our folder. So geo package, it will be soon there and you can download and you can continue with this. So I can open again all the layers. I need to modify this study area again with like this. So in our study area, we have digital elevation model as a raster, and we have input layers as vectors. I said, and it is written in my file, for our study, we will use only raster layers. Because we will use raster calculator, and in raster calculator, it is not possible to use vector layer as an input file. So we need to prepare rasters from our vector layers. We can say we will burn in. So we will have like empty raster with 0 or no data values. And in place where we have hiking trail, we will burn some value into the raster. And we need to set this value, what will be there. So first, maybe we can go to Alpine huts to see attribute table. You see a lot of data. It is all downloaded from OpenStreetMap. So somewhere is opening hours, somewhere is a name. Maybe we can keep only the name. And we will delete all other attributes. Okay. So to be able to delete columns we don't need, we need to start editing. So toggle editing mode, and then we can use this delete field. After this version of file, I will share with you the newer version of this file. So I will delete what I keep. I keep FID, feature ID. I will keep a full ID. I don't need OSM ID or OSM type. So I can go down. Where is the name? Name is here, so I can do it like this. Oops. Yeah, like this. So I will keep only this and this. I will delete what is the blue. And then I will have name. So, okay. It is deleting. I hope it will not crash. Okay, successfully. And then I will delete all other columns there. So behind the name, please delete all what is there. I keep only this 3. And I have rows I need. So this is the name. You can see some Alpine huts in Slovakia, some in Czech Republic, some in Poland. Yes, if you like hiking, I recommend to discover surrounding of Žilina. And especially when you go to Poland or Czech Republic, these trails on borders are very nice. Of course, in Slovakia and Malá Fatra it is, and Slovské Vrchy nice as well. But we don't have so many these Alpine huts like in Czech Republic, in Poland. Additionally, I need a new column with value I will burn in raster. So we can use the button Open Field Calculator, and we will create a new field, and the new value for all features will be just 1. And the name, it could be just value. So we have new column with number 1 for each Alpine hut. And now please save. And same we need to do with hiking trails and with springs, with natural water springs. So I go to hiking trails, for example. And when I open attribute table, again, a lot of attributes there. But what we keep probably is color. So maybe this OSMC symbol, there is the most important information about color, because maybe later we would like to make some visualization, to create, export some map, and it is good to have this map with colors. So yeah, I can see that this column OSMC symbol, it has important information about color. So we will keep this, and we will maybe keep the network, because network, it means regional or local or national or international. So we keep the OSMC symbol and network. And no, we will not keep the name. Yeah. So please, again, toggle editing, and we will delete something. Yeah, simple. We can select all. And what I keep is FID, full FID. And then we are going through. I would like to keep the, where it is, this one, OSMC symbol and network, and I will delete all other.
What does the network mean?
Network, it means local, regional, international. So this is some hierarchy. And additionally, we need to add a column with number 1 for each trail. So please again go to Open Field Calculator. The name, output field name, it will be a value. And the value is number 1. Confirm and save. And the third file we need is natural springs. So we need to do same with the natural springs. Okay, so let's go to see what is in the attribute table. Again, we have a lot of attributes, columns, but I think here for this spring, some of them, they have the name, but it is not so important to keep names. So for this layer, I keep only FID and full ID. We will delete all additional columns. So again, toggle editing mode, delete fields, all except first and second column. And we need to add a new column to burn in location of this point to the raster. And this value, this new column with name value, it has only number 1 inside. So this is last step we needed to realize before conversion to raster. So again, I will remove for a while it from my project, because I will share this new version with you. So maybe I remove the previous version of GeoPackage, or maybe, yes, I remove the previous one, and I will put here the new one. So you can continue your work with this GeoPackage. So for polygon study area, I need this. Okay, so we continue with raster menu, and we go to conversion. And in conversion, we go now to rasterize. First, we used polygonize when we created study area polygon from raster, but now we have it opposite, vector to raster. And when we go from vector to raster, so input layer, we will use, for example, Alpine huts, because we would like to create a raster with Alpine huts. And you see, we have a field to use for a burn-in value. So this is what we prepared with number 1. And this is column with the value. What we need additionally, output raster size. Please select georeference unit, because we have meters and we have a raster that is located in real place, in real world. Horizontal vertical resolution, it will be 25 times 25, because this is in our digital elevation model in this raster. Output extent, yes, we will select that output extent. It will be same as the Seminar 7. This is digital elevation model. And I think this is all what we need. Again, you can see what is GDAL command to do this. First, I will check if I have my parameters correct. So first, I will just create a temporary file so we can run. Okay, it finished. And how to check? So I will keep only these files. And you see, when I zoom in, where I have a point, now I have a cell. Yes, so this is a cell. And I have, of course, more cells there. So I can check using identify feature. When I click on the black cell, the value is 1. When I click to the white cell, there is no data. So this is what I needed. Yes, so now I have new raster with location of Alpen huts. And because this is 25 meter time 25 meter resolution, I think it's correct, because building 20, you see, yeah, like it is okay for location. We can discuss, for example, for water source, if this resolution 25 times 25 it's correct, but when you are 25 meters from some water, it is not very far to go additional 25 meters. So this simplification, this accuracy, is this acceptable? So after we know this raster is correctly created, I will export, I will save it to my files. So save as geotiff. I will keep it in Seminar 7, name Alpine huts. And I keep extent, I keep resolution. Okay. So I can remove temporary file. And you see I have still my Alpine huts. And now I can continue. So now we can rasterize hiking trails. And we do it same way. So go to raster, conversion, rasterize, input layer, change to hiking trails, field to use for burn-in value, output raster, size units, georeferenced units, resolution will be 25 times 25. output extent. So we will use a layer, Seminar 7 raster, or 0 raster, or Alpin HUD. So any raster we have, we can use to define extent. And because now we will be sure, we are sure it will be correct, we can directly save to the file. And the name, okay, it will be in Seminar 7, and the name is hiking trails, and run. So you see, finished, done, close. And now when I hide line vector, you can see I have raster. So this is principle of rasterization, how it works. What is black? This is number 1. This is location where I have my hiking trail, and in surrounding I have 0. There is no hiking trail. Again, you need to think about, in case our hiking trail, maybe it is 1 meter, but if it is 25 meter now in raster, it is not so bad, we can accept. So the last layer we need to rasterize are the springs, natural spring. So please again, go to raster, conversion, and so on. Select natural springs, value burn in, and georeference the units 25 times 25. Output by layer. And now we will save it again directly to the hard disk, and it will be name natural spring, and run. I can check. So when I zoom in, for each natural spring, I have a new cell with value 1. So now I have all input layers as I need it. It means I have all my input layers in raster files. And we will continue with this study next week. Okay. So again, I will upload these TIFF files for you. So I will remove it. Maybe I can remove all. I will upload these files for you. So what is it? Alpine huts, trails, natural springs. This is not, these are not all input files as we need based on my description. So we have Alpine hut, we have water source, we can hiking trails, and we will need a slope. Maybe this slope we can prepare now because we know it from the previous exercise, and we have at least 5 minutes of our seminar. So let us prepare the slope layer. Based on Seminar 7. This is digital elevation model. You remember when we go to raster, raster analysis, we can find slope. A week ago, we were looking at like raster analysis. And it could be raster tenor analysis. Yes, so it can be opened from here. But you see, we have different options. We can have it directly from QGIS toolbox, or we can have it from this library, GDAL library. So let us try this one, slope. Input, it is the elevation model, it is correct. Z factor is 1, and we will save it directly as a file to Seminar 7 folder, and the name is slope, simply slope, and run. We can see some structure there. This is because we had some simplification there. And this is because we created clip from this big file. So, and what is the problem? We changed the coordinate system of it. So you need to be careful. I will create it again to be able to compare. So this is the big area here. I need to clip from this raster again. So I go to extraction. And now it's easy because I have a layer, and based on this layer, I can define the area. So you see, this is different, little bit different coordinate system. So first, I will save this slope as a temporary file, this area as a temporary file. So I have new clip for raster. Then I will do the slope from this new clipped. So maybe this one, slope, clipped, again to temporary file. And you can see that this slope, when you compare with this one, it is without this structure. We can see some lines. Yeah. So it looks like, yes, we have same coordinates, but it could be problem of datum, geodetic datum. So there are a lot of things. So sometimes you need to ask some expert on geodesy, expert on geographic data to continue. I solved this problem a year ago with my colleague from NITRA, from another university. So I will give you this file. First, I will remove. I remove it from my project. I will remove this slope from my folder, this bed slope, and I export it to the folder slope. Now I change it now in this step projection. Now I am curious what happens. I hope it will be not create these crazy structures. No, you see, it's nice. In my computer, I can recognize that it changed something, and you can see it later in recording, that when I am switching between these two slope files, there is some difference. But this is not a problem for us. It allows us to continue. So next week, we continue with these layers. Yeah, this seminar layer, I will change the name only in my project. So it will be DEM, Digital Elevation Model. Then I have slope, and I will use hiking trails, natural springs, and alpine paths. So these are layers we will use in our project next week. I save it like this. And additionally, I upload my slope for you to our Microsoft Teams. So this is all for today. Don't worry. Probably in future, you will not need to work in this detail with this data. But I think it's important to know and understand what could be hidden behind the data. Yeah? What we do the next week, it is work, what I expect from you, for example, for the second test. In the second test, we will have some criteria for decision, but you receive only raster data, and you will continue steps what I learn you next week. Okay, so thank you for today.